Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Robb Aldrich.
And I'm Kelly Westby.
This week is part 2 in my conversation with Steve Klocke, architect and rater here at Stephen Winter Associates. We were talking about his top 10 frustrations, top 10 multifamily design mistakes. And this week we talk about the second 5 on his list. We start by talking about lighting controls, which was probably the one that I found most surprising.
Here's the deal.
All right. I was surprised to see this on your list. I was.
Really? Oh, because it's so often done poorly.
We're talking about multifamily buildings.
Yes.
When there are just lights that are on always. Is that the issue?
As far as I can tell, the only reasons to have lights on all the time is if you're growing pot.
Which is legal for some of our listeners, certainly.
Which is certainly legal for some of you. Or in areas of, egress, etc. The trick is, in areas of egress, so there's a lot of different parts of the code and a lot of different codes that apply to lighting. So here's the gist. 10-foot candles is the norm for supplying illumination to a space.
What kind of space?
Let's focus on egress, I guess, because
Okay.
that's the areas that
All right.
usually get screwed up. Those are the areas. Okay. But when it's not in use, an egress area is not in use, you can go down to as low as 1-foot candle. And that's a big jump in consumption of energy. So, there's parts of the energy code that says you have to have occupancy sensors in these, dozen spaces. It doesn't say you can't have occupancy sensors in these other spaces, right? And so it's a misinterpretation problem.
Okay.
And
so really, you see that it's not that people are lazy and don't care about energy. They think sometimes.
Yes, I do see that too. Yeah.
But sometimes they think the code forbids.
That's my impression.
Okay.
Yeah.
All right.
In rooms like electrical rooms, they for safety reasons, etc. I'm not going to argue with that.
Okay.
But a lot of times you're going to have these stairs where in some buildings we have for security reasons they don't want people to use the stairs, and so they actually kind of make it harder to use the stairs, and yet they've got the lights on 24/7 full blast in there.
All right.
And it just kills me. And so really what you need to do is put in controls. It's all about controls. You know this from an engineering standpoint, Rob. It's all about controls.
Smart buildings.
And now, occupancy sensor, vacancy sensor. What's the difference? An occupancy sensor will turn on when someone enters the room. And it'll turn off after a certain period afterwards to stop sensing that person in the room.
When it stops sensing occupancy.
A vacancy sensor, you typically will turn on yourself, and then it'll turn itself off.
Oh, all right. Okay. No, I wasn't familiar with it. I didn't know that.
And there are some spaces where one is appropriate and some spaces where the other is appropriate.
And that's not a timer. It actually, you turn it on,
Yeah.
and then there is an occupancy sensor that senses you until you leave.
In this room we're sitting in right now, it is an occupancy sensor. And it doesn't matter if the sun is shining bright through the windows.
Right.
This light comes on. It drives me nuts.
Yeah.
And it will eventually shut off, but, think of all the startup, wear and tear on the lights and the consumption, etc. And so, an occupancy sensor makes sense in your egress areas where, look, if it's an emergency, you don't want someone to have to flip the switch and turn the lights on, and you have 100 people, plowing over you because you're the first one through the door, right?
I see. So, as a vacancy sensor in this office in which we're recording, for instance, if someone
office being the operative word there, office is a perfect place for a vacancy
walked into
sensor.
this office, and if I just came in to empty the trash, I just came in to grab my coffee to go get some more coffee.
I came to steal Rob's charger from my iPhone because I forgot it.
So, right. You have to turn on the light.
Yes.
If you want it on.
Yeah.
Or in a lot of the offices, there's plenty of natural light. I see. Okay. So this would be a great place for a vacancy sensor.
Agreed. But not
so
an egress area. No,
in multifamily
that's
buildings, are there what places are good for vacancy sensors?
So offices, closets.
Okay.
You
go into a closet.
Community rooms. Exercise rooms, mail rooms.
Gotcha.
Yeah. Trash rooms. as far as I'm concerned.
All right.
I suppose you could do an occupancy sensor in there because most of them are internal and don't have any windows.
Right.
But in your egress areas, your corridors and all those places, you definitely want an occupancy sensor because that's for safety.
It's a safety.
And we'll never
It's a
try to
safety.
pick a fight with a code official. I mean, we know where we stand.
All right.
But there are nuances that are being missed.
And they're getting better and cheaper.
Yeah,
right?
and I guess you have to balance the short-term versus long-term cost implications. If you're selling this building, you're not paying for the utilities or whatever, you're gonna put in whatever's cheapest.
All right.
If you're maintaining the building, keeping it, you're gonna want something that's gonna minimize your operating costs, and so
And these are
there's
things
that issue too.
that don't come into the ratings a lot of the times.
They're required under some certifications.
I see.
Yeah.
Okay.
And basically what it comes down to is an argument with me. I'm like, they're like, hey, you can't do this. I'm like, well, no, you can. You just need to try a little harder.
All right.
Yeah.
All right.
And you try to say that without hurting anybody's feelings or sounding like a jerk, which is not always achieved by yours truly. But so it goes.
Moving on. I'm gonna let you talk about this one. Oversized HVAC.
I'm glad that as the engineer in the room, Rob defers to the architect in the room to talk about oversized
Just
HVAC.
for my own entertainment.
I think it's going to be a testament to how well I've been trained by the engineers here at Stephen Winter Associates. So the key word here is short cycling. And it doesn't mean a whole lot of people on bicycles that are short of stature. That means, and that's the slide in my presentation, is of my bicycling team from Ragbri in Iowa. Anyway, short cycling means that your equipment is typically of a single speed. It turns on hard, runs hard, shuts off, and it does that in rapid succession. And so what you get is, the analogy I use is a car, or like say you're in a taxi or something like that. If you're in a Crown Vic with a V8 engine, you get in there, the driver pounds on the gas until he hits the red light and then pounds on the brakes. So not only is he wearing out the vehicle faster, he's consuming way more gas than he should. He's making you sick in the back seat, et cetera, et cetera. So if you apply to HVAC, it's humidification or dehumidification, I should say, is the hot topic now as we keep getting these warm, wet summers that seem to be warmer and wetter than in the past. I'm not going to digress into any sort of questionable theories. Anyway.
Good save.
Yeah,
good
geez,
save.
we don't want to make any enemies here. Good thing our house is on a hill here in Norwalk. Anyway, so you're not pulling that latent heat.
Yeah.
That was for your benefit right there, Rob.
Thank you.
Latent heat.
Thank you. I think that's
Which means moisture to the rest of you architects out there.
And thank you for clarifying, because I wasn't going to. I was like, yeah, of course, you're right.
Of course, that's why I knew that.
No, that's I think one of the biggest, probably the biggest issue with oversizing is not dehumidifying in a humid, warmer, humid climate. You really don't get the dehumidification.
Yep. Yeah, so you're not achieving the efficiency that your equipment's rated to because it's short cycling. You're wearing it out. You're not getting dehumidification on the cooling side. And it's just uncomfortable. Like who wants a cold, hard blast of air on their necks every 10 minutes, right?
Yep.
You'd rather have sort
Even
of more
temperatures.
even, kind of a smooth operation, ramp up a little bit, ramp down a little bit. Smooth operator is what we aim for.
It's interesting. So you can make an argument that some fuel-fired heating systems, there's not a big efficiency penalty to oversizing.
Especially those that ramp down, like, boilers, for example, can just go at a tenth of their, what is that? What's that term,
modulating.
Mr. Engineer? Modulating, but turn down? No.
Turn down, sure.
Yeah, that's the term I'm looking for.
Yeah, if you can modulate down 90%, turn down 90%.
Yep.
That's pretty good.
Turn down service.
But I think it's a comfort issue.
Yeah.
It's a humidity issue.
Yeah.
And it's a cost issue.
Oh, yeah?
I mean, if you put in, especially with air conditioning, you put in twice the capacity you need, you pay almost twice as much.
Yeah, but Rob, what if you're going to add on someday? You really want that extra capacity, man.
What We're talking about multifamily buildings.
Oh,
Who's
right.
going to add
That's
on?
true. That's single
Who's going to
family.
add on, Steve?
I
Come
had
on.
a new house recently where I was like, oh man, did you get sold? Anyway, next one.
Next one. And this is actually, I've been dealing with this tons lately on, I'm sorry, the oversized HVAC.
Oh, we're going to dwell on that one already.
Just give me a moment. With heat pumps, which are really taking over in a lot of things.
Everybody thinks that, the heat pump is no problem. It's
Right, it
totally
can modulate
up
down,
and
no
down, up
problem.
and down. No.
It has a really big efficiency and comfort potential drawbacks when you oversize.
Oh, yeah. Well, I was in a townhome in Brooklyn, in Park Slope, actually, where millions of dollars of art on the walls, and it's getting ruined because they got these great VRF systems, but they're just too darn big. Yeah. No good.
All right, we need to do another episode on humidity. Too much. All right, moving on. For real this time.
For real.
Antiquated ventilation.
Yeah. So I start off in my presentation with, the old school way of dumping a bunch of air into your corridors, undercutting your apartment entry doors and expecting the air to get into the apartments. Not only is it not allowed by mechanical code, it's not allowed by fire code. This is when I still
With an
unfortunately
exhaust
see
fan. So we're talking about an exhaust fan.
Yeah, exhaust out of your apartments and your makeup air. Makeup air is, I realize that it's important in some areas. In this area, it's not applicable. It's makeup air is coming from the wrong place. You don't want to be pumping air into the middle of the building and expecting it to get to where it needs to be.
Gotcha.
Right. You need to control the air. So by antiquated ventilation, we're basically meaning we got to take it up a couple of notches as far as, and let's turn the equation backwards. What if we have central exhaust and then we've got trickle vents and air vents and things like that, and unfortunately, we're pretty guilty of this. We've said for a while, based on program clarifications, that trickle vents are required. And I've done a few studies, I'm fairly sure you can tell me better, that show that they really don't work all that well because you get all kinds of stratification in tall buildings and stack effect and all kinds of funny things are happening when you take control away from your ventilation system. It needs to be controlled.
And both the exhaust and supply.
Exactly, both sides.
Okay.
Yeah.
You can't do one and hope the other side works itself out.
Right.
And that's, oh my God, for a century that's been the standard. Where you just suck air from the kitchens, you have a big mushroom fan on the roof, so it's big stack, sucks air from bathrooms and kitchens, and there you go.
Yeah.
You're all done.
Well, I still get asked why we have to have exhaust in kitchens. So
We have Kelly's doing a separate episode.
Okay, we're just not going to dwell on that one.
There's a hot topic also.
Hot topic.
Passive house and IEQ people are butting heads over it.
Yeah. I stay out of that.
So what would you like to see? I mean, we're talking balanced ventilation, we're talking ERVs, HRVs. What's good?
Well, it's a matter of what you can stomach. So
We're talking money? What are we talking?
Yeah, basically. Okay. Yeah.
All right.
I mean, the extreme end of the spectrum is balanced ventilation through an ERV, HRV.
Okay.
I feel like that's the direction that code is going to go eventually.
Programs, certainly, I think.
As soon as the people who have been fighting it thus far run out of gas, Robb says no, reading his body language. I just don't see how with more and more studies that come out about the value of indoor air quality, I don't see how we can keep not doing that.
I don't disagree. This is a whole other topic, but so many of the balanced ventilation systems I see, ERVs and HRVs, they may not be installed properly.
Oh, yeah.
And that's a big deal. They may not work from day one. And if they do work on day one, they're maintained so poorly or not at all that they don't work even like 6-9 months after occupancy.
Yeah.
So that's a big deal. And that I think is one of the more valid arguments against mandating ERVs and HRVs. Yeah. But you can't argue with the performance benefits, with the health benefits, with the indoor air quality benefits.
Well, in our house, your own house? Our own house. We renovated, LEED Platinum, exhaust only ventilation strategy, meets ASHRAE. Mm-hmm. All the boxes are checked, and then after living in it a year, we're like, no, it's too stuffy.
Huh.
We're not getting. I feel like I'm physically affected because I don't have enough fresh air.
Huh.
And so we put the ERV in, and it literally was a night day difference.
Oh, interesting.
And so
All
here's the
right.
deal: do they cost more to install? Yes. Do they cost more to operate? Yes. Do they?
Well, the
really?
energy savings can certainly make up for.
Right. Well, in our house at least, we had turned up the flow rate above the exhaust only, what we had for exhaust only. So in our case, that was the case. That it cost more to operate and
Okay.
there's more air to heat and cool, basically.
All right.
And it took up space in the attic, yada yada yada. But you know what? I mean, when it's your family, and you don't think you're as healthy as you should be, I mean, it's a no-brainer. Now, as a designer, it's different, you know. But I guess in my presentation I say, look, try to think if it was your kids or your family. I mean, if you're living in these apartments, I know what the constraints are, but you know, it's something to consider. I tug at the heartstrings.
No,
At that part.
there's no argument about the benefits.
Yeah.
It's it'll be interesting to see what happens.
Yeah.
And there's better ways to do it. Maybe there are better products coming. I hope.
Yeah,
I hope.
yeah, we're slow to it here in the U.S. I mean, I guess in
It's
Europe
and in Canada, it's much.
Yeah.
It's very, very common.
Yeah.
And in a multifamily building with good property managers, with good owners,
good maintenance.
they
yeah.
can be maintained
Yeah.
really well. So, all
Well,
right.
I mean, do you buy a car and not change the oil every 5,000 miles or
Yeah.
whatever? Well, yeah,
Most people don't.
right,
But on ERVs and HRVs,
yeah.
most people do.
Well, this is the luxury I have of it just being an hour presentation. I can say what you're doing wrong and not worry about the bigger consequences.
All right, all right. Enough about ventilation. Good?
I know you
good?
want to dwell on that, but maybe that's a whole nother podcast.
We could go on and on and on.
Yeah.
But we won't.
Okay.
Domestic hot water.
Domestic hot water. This is one where I
Specifically
reached
distribution. you have
distribution.
here.
Yeah.
Okay.
So I had always wondered before I got into this. I had always wondered how the hotel hot water works. How is it that it's a big hotel and I can turn on the faucet and I get hot water right away?
Scalding right away.
Scalding hot water. And I wonder, how does that work? And now I know, right? There's hot water coursing through the building 24/7. And so you can't get around that. I mean, people are going to want their hot water and not have to wait for it. So at this point, the best you can do is make that system as efficient as you can. And that means this is the most technical part of the presentation. There's a diagram showing a 3-pipe domestic hot water recirculation system and a box design. And basically all it is taking the return side, the hot water return, and shortening those runs. Instead of taking them back down the risers that they came up, so in a multifamily building, you're going to have hopefully you have your hot water generation on the roof. It's coming down a shaft in the middle of the building and then getting distributed horizontally and then back up again into the various apartments. And then it goes back down again, over again, and then up again, right?
Yeah.
So instead of taking the return water back down to the building, you just take it across the top of the building. You take a shortcut back to where it came from in the first place. And so basically, if you can reduce your pipe length, if you can also reduce your pipe diameter, I mean, so surface area, right?
Yep.
And so, a lot
insulate it really
and
well.
if you can insulate them, right? Well, back to pipe diameter. I mean, in New York City, at least, we have to have low flow fixtures. In any of our green programs, you have to have low flow fixtures. And engineers are still designing their pipes to the high or medium on that ASHRAE chart, right? And so they should be going no more than the low. Because unless everybody in the building yanks their shower head on the first day they move in and puts in a 9 gallon per minute or whatever.
Seinfeld episode comes to mind.
Really?
Yes.
All right. I'll have to take your word for that. A word on that. Anyway, you don't need those big pipes. The bigger pipes, bigger loss. Yeah. So longer pipes, more loss. And insulation, just making sure you've got your details in there. Get those things insulated. And yeah.
And this is something where we'll put the link to your one of your PowerPoints up on the site.
Sure.
Because this is, and others here have done some work on this, because it's much easier to get a handle on this when you're looking at diagrams.
Yeah. It's a very visual thing.
Yeah. But you're right. I mean, people are It's the oversizing thing again. It's overkill.
Yeah. Yeah, and
it's a CYA.
Not throwing engineers under the bus, but you are a conservative lot. I'm just gonna say it.
And good thing.
Sometimes.
It's not inappropriate. That's not a bad thing.
Sometimes.
All right. How about controls for DHW distribution?
I didn't get into that.
With all right. Well,
you are welcome to
get into it right now.
Rob, tell me about controls.
So, like you said, in hotels, there's this big loop that's pumped 24/7.
Yeah.
And in hotels
controls.
and in larger multifamily buildings, that's pretty much necessary.
Yeah,
I think, to pump 24/7. In smaller multifamily buildings, I think there's potential for demand control.
Sure.
So there's super simply, if there's like a flow switch that senses if anybody is calling for hot water.
Mm-hmm.
And whenever anybody's calling for hot water, then a pretty large pump comes on, primes the system very quickly.
Mm-hmm.
So people wait, very short amount of time. But then when nobody's calling for hot water, it shuts off, and you're not recirculating hot water throughout the building.
Midnight to 4 a.m. is.
No, but you don't want to discriminate against people on the second shift.
No, I'm just saying, though, that, instead of running full blast all night, there's, like you said, there's savings to be had there.
Yeah.
For sure.
All right, we'll move on. Lastly, but not leastly, poor communication.
Yeah, so is that a design mistake? And so here's what I say. Yes, it is.
Yes, I agree with you.
Because what is your job as an architect or an engineer? It's, what is your product, I should say? Your product is not the building. Your product is not the MEP systems. Your product is the design, is the drawings and specs. That's your deliverable. And so if you cannot convey what you're trying to achieve through those drawings and specs, you're not living up to, your role as a designer. And so, it's making sure that you're getting everything that you need to on paper, but you're also getting the feedback you need. So architects, are you listening to your engineers, or are you just throwing background drawings at them and expecting them to make it work, with whatever? Architects, they've got their hands full with all kinds of other things, right?
Oh,
and so, engineers just one more, input to this whole big machine that technically they're responsible for. But, the best projects I've seen is where the architects and engineers have a real partnership and they communicate back and forth. And, an engineer will tell an architect, well, why are you drawing it like that? Why don't you, if you could just do this, this, and this, our systems would be that much smaller. And, so it's got to be a two-way street as far as communication goes.
And there are more and more people involved, like through the rater, to the passive house consultant, to the sustainability consultant. If your feedback gets incorporated.
This might be slightly biased, but yes, one big important point is listen to your consultants and actually, again, have that two-way dialogue. And we're not here to just tell you how much your design is not right. We want the building to be better. We've been improving the built environment since 1972, I'm fairly sure. 6 years before I was born, but I was thinking about it. But anyway, yeah. So and also construction. I was up in an attic out in Long Island on Tuesday this week, and we're up there, and I'm like, I'm sorry, guys, you just got sort of backed into a corner here. Like, I couldn't have done this any better than you did, but it's still not where it needs to be because of the limitations that were placed on you by the design. And so, the good architects will get out there and they'll get their boots dirty and they'll talk to the people who are actually building their buildings, and they'll learn from it.
Oh, absolutely.
Yeah.
You learn so much being out in the field and seeing screw ups more than anything else. I gotta say,
learning from mistakes. Yeah. Well, and not even necessarily mistakes, but maybe just things that could have been done better. If you can get out there and communicate with the guys and gals who are actually making it happen, they have a lot they could teach you. And I learn every time I go out. I learn something from, just some random plumber, and I'm gonna put that in my toolbox, and contribute that in the future because I would never known.
And it goes both ways. I mean, I've explained to various trades, the importance of an air barrier, what we're trying to accomplish, and it's not necessarily straightforward.
No. Well, and I get a lot of good suggestions. They're like, "Oh, what if we did it like this?" And I'm like, "Yeah, you could do it like that." Right. So just as designers, I don't know if the siloing is the right term, but don't put yourself in a place where you're not willing to take feedback, basically. So communication is, making sure what you're putting out there is good in the first place, and then, being willing to hear feedback on it. And the other thing, and it actually feathers back into number 2, which is design irregularities. Engineers are really good at having a pile of stock details that they'll apply depending on what kind of system they're working with. Architects, not so much. Some are.
Is that right?
Right.
Okay.
I don't think, at least. Personally, I don't feel. I mean, it's not like...
If you're drawing a window detail from scratch every time, you're doing...
Exactly. Or if you're redrawing the same detail 2 or 3 times, it's a bad detail from the beginning. Like, so what you do is you learn from good designs. You put them in your own little virtual toolbox, right? You say, for wood construction, this is how we do it. For steel construction, this is how we do it. You've got those stock details. Use them. Spend your time, instead of wasting your time trying to redesign the wheel a little bit every time. Build yourself a good stable of, details.
Yeah, absolutely.
And then either A, spend the rest of your time, actually charge your clients less. There you go. There's one thing. Make the project affordable overall. B, spend your extra time on making the building better in other ways. Or C, just go golfing, spend some time with your kids, be happy, whatever. Right?
There you go.
Yeah, I mean, why are we spending our time?
You're solving all the world's problems.
Cutesy wootsy little details. And I'm not trying to be making any enemies, but I've got a builder in New Jersey who does affordable senior living developments, and in an 80-unit building, there are 3 unique designs. 3. 80 unit building, 3 unique designs. Guess what? He can't build these things fast enough. People love them. They're relatively efficient. And so it's like, are they winning any design awards? Not necessarily. But is he providing affordable, healthy, efficient places for elderly people who need that sort of thing? I mean, it's nice to have a design trophy on your shelf, but gosh, I don't know. I would sleep pretty good if I was saying that I was providing that.
Right on. Fantastic.
Yeah. That's the gist of it right there.
Right on. That's 10. We did pretty good.
We did.
Less than an hour.
Yeah.
Any other concluding comments? Anything to wrap up?
Yeah, so basically, at the beginning of the presentation, here's where it starts. Design decisions made in the office have a snowball effect throughout both the design process, the construction process, and the life of the building, right? And the earlier you can make good decisions, the better off you're going to be, or your building's going to be in perpetuity. Thanks.
Well done.
Thank you. And so someone asked me as I was asking around the office, for suggestions on design mistakes and what I should incorporate in this thing. As he said, well, have you thought about why people keep making these bad design mistakes? And, that's a good question. It's very meta or whatever you want to say. And I thought about it, and it's like, design is just decisions. It is decision after decision after decision after decision. It's endless. I mean, that's really all design is you're deciding to do one thing or another, right? So here's the thing. If you don't know that's what design is, how can you actually make good decisions? Right? How can you move your design forward if you don't realize that every time you put that pencil down to paper, which nobody does anymore, obviously, but every time you click that mouse, you're making a decision. So, valuing those decisions is important, and it's super hard to keep in mind, and also very fluffy. But really, that's where it's at. I mean, because who else is going to do it? I mean, all these buildings keep popping up, or do they happen spontaneously? Yep. No, people are drawing them, people are developing them.
Right. So, you don't want to be by rote. Being mindful, being conscious, learning. Yeah. I'm with you.
Yep. There it is.
Thank you very much, Steve.
You're welcome very much, Rob.
Thank you for listening to Buildings and Beyond. For more information about the topics discussed today, visit www.swinter.com/podcast and check out the episode's show notes. Buildings and Beyond is brought to you by Stephen Winter Associates. We provide energy, green building, and accessibility consulting services to improve the built environment. Our professionals have led the way since 1972 in the development of best practices to achieve high-performance buildings. Our production team for today's episode includes Dylan Martello, Alex Mirable, and myself, Heather Breslin. Thank you for listening, and we'll see you next week.